Yes, welcome back to the session. In this video, I'm going to discuss about electric potential due to a dipole. Okay, so look at this diagram here. Dipole means we have two equal and opposite charges, right? So one is a positive charge, another one is negative charge, which are separated by a distance a plus a, 2a. Okay, so what I'm going to do here, I'm going to calculate electric potential at this point. So that is the reason I'm connecting a line from point P to center. Let us assume the distance of separation is r. Similarly, from point P to positive charge, the distance of separation I'm taking r2. Similarly, from point P to minus q, the distance of separation I'm taking r1. Okay, so look at this diagram carefully. As compared to r distance, r2 is very small and r1 is very large. Am I right? So what I'm doing here, I'm going to equate the r2 distance which is equal to r. For that, I'm connecting a line from positive charge to the central distance. It touches the central line at a point M. Okay, and it makes an angle theta. So what I'm taking here, now I'm taking triangle PO plus Q. From this, I'm taking the component cos theta. So we know that cos theta is nothing but adjacent side by hypotenuse. Am I right? So here, adjacent means OM by hypotenuse means A. So cos theta is equal to OM by A. From this, OM is equal to A cos theta. Am I right? So I told you already. Now what I'm doing here, R2 distance I'm going to equate with R. So that is the reason I'm taking R2 is equal to R minus OM. Am I right? Yes. So R minus OM formula already we know. A cos theta. So this is R2. Similarly, same like that, I'm going to calculate R1 also. Okay, let's see. So to calculate R1, look at here, as compared to the distance R, R1 is very large, right? So that is the reason I'm extending this R in outward direction, I mean downward direction like this. Now I'm connecting with negative charge. Now R1 and R plus ON. So this is O and this is N. So we can write it as R1 is equal to R plus ON. Okay. Now I have to calculate what is ON here. So to calculate ON, I'm taking a triangle ON minus Q. Okay, so triangle ON minus Q. From this again, cos theta is equal to adjacent side by hypotenuse. Okay, so let us assume this is theta and ON, this will be the adjacent. So ON by hypotenuse means A. Okay, so finally I got cos theta is equal to ON by A. From this, ON is equal to A cos theta. Okay, so I got ON formula. So this ON formula I'm going to substitute in this. So R1 is equal to R plus ON means A cos theta. So finally I got R2 formula as well as R1 formula, right? So my final aim is I'm going to calculate electric potential at point P due to positive charge as well as due to negative charge. Okay, so I'm going to write a step by step. So first I'm going to calculate electric potential at P due to negative charge is V1 is equal to 1 by 4 pi epsilon naught into minus Q by R1. Okay, So here R1 formula already we know, so we can substitute there. Let's see. So which is equal to 1 by 4 pi epsilon naught into minus q by R1 means R plus A cos theta. So let us assume this is equation number 1. Okay, same like that, I'm going to calculate electric potential at point P due to positive charge. So I'm going to write electric potential at point P due to positive charge is V2 is equal to 1 by 4 pi epsilon naught into plus q by R2, right? What is R2? R2 means R minus A cos theta. Directly I'm writing here R minus A cos theta. Let us assume this is equation number 2. So finally I got V1 value as well as V2 value. So based on this V1 and V2, directly we can calculate net potential at point P. Am I right? So therefore from 1 and 2, I'm going to calculate net potential. Okay, so we know that net potential is equal to sum of V1 plus V2. Okay, so V net is equal to V1 means 1 by 4 pi epsilon naught into minus q by R plus A cos theta plus V2 means 1 by 4 pi epsilon naught into q by R minus A cos theta. Okay, now I'm going to rearrange the step. At the same time, q as well as 4 pi epsilon naught terms are same, right? So the constant terms, I mean common terms, I'm going to take it out. Let's see. Q by 4 pi epsilon naught I'm taking outside. The rest of the term, the positive term I'm taking first. What is the positive term here? 1 by R minus A cos theta minus 1 by R plus A cos theta. Okay, so this term I'm taking here and this term I'm taking here. Okay, so after writing this step, I'm going to take LCM. Let's see what will happen. So Q by 4 pi epsilon naught into R plus A cos theta minus, this goes this side, R minus A cos theta by the denominator terms we can write it as R square minus A square cos square theta. Okay, so look at this equation carefully. So this is plus R and this is minus R, and then minus of minus becomes plus, right? So the next step, so look at this equation carefully. I'm going to change the next page. Okay, so therefore V net is equal to Q by 4 pi epsilon naught into A cos theta plus A cos theta. So we can write it as 2A cos theta by R square minus A square cos square theta. Okay, so we know that electric dipole moment P is equal to Q into 2L. Okay, so instead of 2L I'm taking 2A, so Q into 2A. So look at here, 2A is present and Q is present. So therefore net potential we can write it as P into, what is the remaining term? Cos theta by 4 pi epsilon naught into R square minus A square cos square theta. Okay, now coming to the diagram, look at this diagram carefully. Here the distance A is very small as compared to R, correct or not? So that condition I'm going to take here. If R square term is double greater than A square cos square theta, so we will ignore this term, so no need. So therefore the net potential is equal to P cos theta by 4 pi epsilon naught into r square. Okay, so I hope you understand. Thank you so much.